In this part of the course, we will take a look at infinite limits and limits at infinity. Let's start with infinite limits. An infinite limit is, as you would expect, infinite for x going to a. So basically, an infinite limit is a limit of some function f of x, that if x goes to a, this limit becomes plus or minus infinity. So it means that when x approaches a, so when x gets closer to a, the limit value will move towards plus or minus infinity. So the limit value, the value of the function, becomes arbitrarily large. Some examples are the following functions. Let's say we want to find the limit of 1 divided by x squared for x going to 0. A quick plot of the function reveals us the solution. We see that both the left limit and the right limit give arbitrarily large values, so both sides go to plus infinity. We can therefore state that the limit for this function will be plus infinity. However, please note that the limit does not really exist. So we write it down as plus infinity, but the limit does not exist. Because the values become arbitrarily large near x0. As a second example, take the function f of x is 1 divided by x. Again, first plot the function and then inspect the limit. We see there is a difference in limit depending on the side of which we approach 0. If we arrive from the left side, so with negative values, the value of the function goes to minus infinity. If we approach from the right side, so with positive values, we see that the value goes to plus infinity. So we can say that the left limit of f of x, so x to 0 with values smaller than 0, is minus infinity. The limit from the right, so x to 0 with positive values, is plus infinity. But we see also that the left limit and the right limit are different. And so the limit itself for x going to 0 does not exist. Again, a limit being minus infinity or plus infinity in itself also does not exist, but we can say it is plus infinity or minus infinity because the value becomes so large or so small that we can give an idea about the size through infinity. If the left limit and the right limit are different, it means that there is no limit. So there we say it does not exist, we write it with a dash. Now what would be the limit for x going to 0 if we have a function 1 divided by x squared minus 1 over x? This function is not as easily to plot as the previous ones, and so you cannot rely on a graphical interpretation. So what you will do is you will try to solve it either on site or using a sign chart. So what we have is that this limit is also the limit 1 minus x divided by x squared for x going to 0. And now what you will do, you will create a sign chart for the function. Why do we do this? Because we know if x approaches 0, this function will become arbitrarily large, but we cannot say on view whether it will be plus infinity or minus infinity. So we take a sign chart, which means we take both the numerator and the denominator of the function and we see what happens in the special points. So we have 1 minus x, we have x squared, and then we have the function in itself 1 minus x divided by x squared. Now what are the important x values that can have an influence on the sign of my function? The numerator is 1 minus x, and so the influencing point here is the point 1. So an x value of 1 might have an influence on the sign. Similarly, for the denominator, we have x squared, so here the value 0 is of importance. If we then look at the signs within these intervals, we see that if x is smaller than 1, 1 minus x is always positive. So here this is positive and this is positive, but once x becomes larger than 1, 1 minus x becomes negative. On the other side, x squared is always positive because we have a square. If we then combine these results, we see that 1 minus x over x squared in the point 0 does not exist, so we put a full line here. It's a non-existing value, and in 1 we get a value of 0. Now what's the sign? For the first one we have plus and plus, so this means we have a positive sign. We divide something positive by something positive. The second part, positive divided by positive, is also a positive sign. The third one, a negative part divided by a positive part, will give me a negative final sign. This means, in conclusion, that the limit of f of x, so of 1 over x squared minus 1 over x, for x going to 0 with negative values, is plus infinity, because we have a positive sign on the left side. The same way we see that the limit for x going to 0 but with positive values of the function is also plus infinity. And so we see that the left limit and the right limit are equal. And thus also the limit itself will be plus infinity if x moves to 0. So in general, if my limit is a divided by something that's equal to 0, then we know that we have an infinity, and the way to see if it's plus infinity or minus infinity is through a sign chart. So sign chart to decide whether the limit is plus infinity or minus infinity. Strongly linked to infinite limits are vertical asymptotes. A line x equal to a is a vertical asymptote of the function y equal to f of x if at least one of the following is true. Either the left limit, so the limit for x going to a from the left side of the function is infinite, so plus or minus infinity, or the right limit of f of x for x going to a, so a from the positive side, is plus or minus infinity. So we have a vertical asymptote at the point a if either the left or the right limit becomes extremely large either positive or negative. So if we look back at the previous examples, we see that for the first one we have a limit going to plus infinity at the point x equal to 0. So here, this line, the line x equal to 0, will be the vertical asymptote. So we will abbreviate it as VA, vertical asymptote. For the second example, we have that the left limit in 0 is minus infinity. So already x is equal to 0 qualifies as a vertical asymptote. And also the right limit goes to plus infinity. So it is twice the same vertical asymptote. So here, this line x equal to 0 is again the vertical asymptote of the function. Let's then take the following function. F of x is 2x divided by x minus 3. The plot shows us that the function has a curve downwards to minus infinity if we approach 3 from the left. And on the other hand, if we approach 3 from the right, we have a curve which moves upwards to plus infinity. As such, we can say that the vertical asymptote is the line x equal to 3. We can obtain the same result either through reasoning or through a sign chart. If we just think about the function, then we see that the limit of 2x over x minus 3 for x going to 3 from points on the left side of 3, this limit will be minus infinity. Why? Because if x is close to 3 and smaller than 3, then you know that on the one hand x minus 3 will be a small number but negative, and 2x will be close to 6, so positive. And so when we divide, we get a positive number divided by a small negative number, and the end result is negative, so you get minus infinity. If you go for the right limit, so you go for x to 3 plus, then if x is 3 but larger than 3, then you know that x minus 3 is a small but positive number. 2x remains close to 6, but you now have a positive number divided by a positive number will give you positive infinity. So a positive number divided by a very small positive number will give you a very large positive number, so we will go to plus infinity. This corresponds to the following sign chart. So the important points are 0, which is a 0 from 2x, and x equal to 3, which is a 0 for x minus 3. So we know 2x is 0 for x equal to 0. We know that x minus 3 is 0 for x equal to 3. If we then look at the signs, 2x is negative here. It is positive once we go larger than 0. Same thing, x minus 3, everything smaller than 3 is negative. Everything larger than 3 is positive. If we then look at the combination 2x divided by x minus 3, we know that here the function is 0 in 0 and it will not exist in the point x equal to 3. Now, what are the signs? The first part we divide negative by negative, so this is positive. The second part we divide positive by negative, so this is negative. Third part, positive divided by positive, will give you a positive sign. And so also on the sign chart you see that if you approach 3, so if you approach 3 from the left side you have a negative sign, so it will be minus infinity. From the right side you have a positive sign, so it will be plus infinity. Left limit is minus infinity, right limit is plus infinity. The limit itself does not exist. So for a vertical asymptote you can say in general that x equal to a is a vertical asymptote if the point A is a 0 of the denominator but not of the numerator. So basically, if in your limit point A you obtain a limit of a number, a real number, divided by 0.